Okay. So in the last class, we discussed some basic functions, namely constant function, identity function. After that, we saw the graphs of polynomial functions. Polynomial, the general behavior also we saw how a linear, as we go on increasing the degree, how the graph changes. The leading coefficient means the coefficient of the highest power. Coefficient of the highest power is the leading coefficient. Its signature determines whether the graph is facing upwards or facing downwards. And as the degree goes on increasing, how the graph takes its turns from straight line to U to the cubic, then biquadratic, and so on. Then quadratic expression, we analyzed completely how the expression looks like. It's a parabola, or in the rough language, you can call it a U shape. The two important remarks regarding that U shape is it is symmetrical. The bottommost point of the upward U, topmost point of the downward facing U. The x coordinate is minus b upon 2a. So the graph is symmetrical about that vertical line x equal to minus b by 2a. And if a is greater than 0, if a is greater than 0, then graph is an upward facing U. Since it is an upward facing U, so the minimum value of the graph occurs at x equal to minus b by 2a. Means whatever is the image of minus b by 2a, that will be the minimum value of the graph. And if a is less than 0, that will be the corresponding maximum value. This helps us determine the range of the quadratic expression. Questions related to domain of the quadratic expressions also will be asked using these properties only. Okay, and we did some questions regarding find the range of such questions. So now let's move on to new functions. I think this was.
Sir,
yes, tell me.
Sir, can I ask you one question which is given by our school, sir, today? One homework question they gave, sir.
Regarding which chapter it is?
Complex numbers and quadratic equations.
Okay, so can after if after 6:30 you're free, can we discuss it after that time?
Okay, sir. Okay, sir.
Okay, I will wait. I will give you some extra time after 6:30. Don't worry, we will discuss at that time. Okay.
Okay, sir. Thank you, sir.
Okay. So let's continue further with the functions and relations, the graphs. The next function that we want to deal with is the absolute value function. So this is, I think, function number 4. Absolute value function, it is also called as the modulus function.
So is this the fourth type?
Fourth?
Of basic functions.
Yeah, basic function is some fourth type, or I think fourth or
it's fifth, I think so.
Fifth, I think.
Yeah.
Modulus function. So what is the modulus function? Means if f is defined from R to R, where f of x is equals to means now absolute value function, you know the meaning of the function already. So what is the meaning of the function? I will give the definition afterwards. So the meaning of this is something like this. So modulus of -3. Modular absolute value means you have to take just the numerical value. So modulus of -3 is 3. So modulus of 5 is what? So modulus of 5 is 5 only. Modulus of 7 is 7 only. Modulus of -7 is also 7. This function you already know. So just how to define it. So I will define it. If f of x, it is represented by modulus of x. That is the representation. Mod x, you can read it as mod x or modulus x, whatever. And what is the definition? If suppose you can write modulus of x equal to x, but I want the positive values. It is if x is greater than 0, then I will just write x is greater than or equal to 0. I will just call it mod x equal to x. As you can see, sir, what is the value of mod 5? It is 5 only. But if x is less than 0, then in that case, what you will have to do? If x is less than 0, like modulus of -3. So now you want the result to be 3. So you will define this function to be minus of x. So do you see that when I define modulus of x equal to minus of x, and as soon as I put mod of minus 11, suppose. So your x is equals to 11. So x is equals to, sorry, x is equals to negative 11. Since x is negative, so minus of x, minus of minus 11. So ultimately the answer is positive. Understood the definition? This is just a way of writing mod x is equals to x if x is greater than or equal to 0, and equal to negative x if x is less than 0. Okay. So this is the definition. And now the graph of this function looks something like this. Now this is my image axis, y is equals to mod x, and here is my x-axis. So if we just concentrate now here, take note, then whenever a function, it changes definition according to the range of x, according to your value of x. Means here x interval, the x-axis. To the left of the y-axis and to the right of the y-axis, the function has different definitions. So to the first, we will draw the graph for the right part. So for the right part, if we draw the definition, if we draw the graph, it is something like modulus of x we are plotting on the y-axis. So my y coordinate is equal to x on the right hand side part. If x is greater, to draw the graph of y is equals to x. So for greater than 0, this straight line you know to draw. For x equal to 1, it will be 1. For x equal to 2, it will be 2. For x equal to 0, it will be 0. This will be a straight line. Okay. And for left hand side part, for the left hand side part of the y-axis, that is for x less than 0, what graph you have to draw? You have to draw graph of y is negative of x. So y is equals to negative of x, or when x is minus 1, y is equals to plus 1, x is minus 2, y is equals to plus 2, x is minus 3, y is equals to plus 3. If you draw the graph, it will be this way. Actually, it's a mirror image about the y-axis. This bottommost point of this V-shaped graph, the bottommost point is x equal to 0. This is the graph is equals to mod x. Now, I don't think this will be very much difficult to observe that now just state this part, because this part we have seen a slight introduction to the transformation of graphs while analyzing quadratic expressions. If I tell you to draw the graph of modulus x plus 2, or let me draw here, f of x is equals to modulus x addition 1, let's say modulus x addition 1. So can you see that this graph that I drew for modulus of x, it will get shifted 1 units upwards. The whole graph will get shifted 1 units upwards. This is the graph of modulus of x plus 1. This part we'll see again in the special chapter, transformation of graphs. And modulus of x plus 1 you can draw. Modulus of x minus 2, f of x is equal to modulus of x minus 2. This graph I give you as homework. I think you should be able to do it. Now, graph of, here it was mod x. Now I am telling you draw the graph of f of x is equals to, instead of mod x, draw the graph of mod of x minus 2. Instead of modulus of x, now draw the graph of x minus 2. So convince yourself that the graph will be something like this, x equal to 1, x equal to 2. Exactly V-shaped graph, just the bottom of that V shape will be at x equal to 2. At x equal to 2, the graph is 0. One step to the right 2 and one step to the left of 2. One step to the right of 2 means at x equal to 3. So the bracket, the inside the modulus, it becomes 3 minus 2, that is 1. So modulus of 1 is 1. one step to the left of 2, that is at x equal to 1. At x equal to 1, the inside the modulus sign it becomes 1 minus 2, that is minus 1. Its modulus is 1. Similarly, 2 steps to the right of 2, 2 steps to the left of 2, something like this, and the graph will be this. Symmetrical about the vertical red line. What that vertical red line is, the vertical red line passes through x equal to 2. Okay, then modulus of x minus 2, addition 1 you can draw. I think f of x is equals to modulus of x minus 2, modulus of x minus 2 plus 1, and modulus of x minus 2 minus 2, something like that also you can draw. F of x is equals to modulus of x minus 2 minus 2, let's say. So this graph I will draw for you. The mod x minus 2, this graph will be something like this. The mod x graph is shifted 2 units downwards. These two graphs you will be able to draw. Okay, and the last, f of x is equals to minus of mod x. So minus of mod x. So mod x, to take negative of that. So you have to take negative of that. So graph will be something like this. Symmetrical about this line. Clear? Minus of modulus of x minus 2. This is the point x equal to 2. Okay, this is x equal to 1, x equal to 2, symmetrical about that vertical red line. Till here, any doubts to anybody? Dhananjay, Pujita, Nitin, any doubts?
No doubts, sir.
Yes.
Okay, so this is the absolute value function. Question number 1. Modulus of 2x minus 5 is equals to 37. X is equals to question mark. No, 21 and minus 21 is the wrong answer, Dhananjay. Pujita, 31 by 2 also, I don't think. No, Pujita, that also is wrong. C. Modulus of something, modulus of y, let's say 2x minus 5. Consider that to be equal to y. Modulus of some number, I don't know what that number is. Modulus of some expression. However complicated that expression is, we need not bother. If modulus of something is equals to 37, so what that something is, either it is equals to 37 or it is equals to negative of 37. Yes or no? If it, even if it is negative 37, then also the mod turn out to be 37. So what do I have to solve? I have to solve two equations. 2x minus 5 is equal to 37, or 2x minus 5 is equals to negative of 37. So solve these two equations, you get x is equals to 37 plus 5, 42. 42 upon 2 is 21, or x is equals to negative 37 plus 5. So now negative plus 5 is negative 32, and negative 32 upon 2 is negative 16. What Dhananjay did was he calculated 21 and second part without calculating, he just directly wrote minus 20. X is either 21 or x is equals to negative 16. Clear?
Yes, sir.
Okay. Question number 2 now. Find the domain of modulus x minus 10 under root. In order to make this a function, you will have to remove all the problematic points. So just remove all the problematic points and make it a function. Okay, C. Mod x minus 10, now solution. In order for this function to be defined, whenever there is under root of something, let's say under root of y. So in order for this to be defined, we know that under root, whatever expression inside the under root sign, that should be greater than 0. For the real valued function f of x is equals to mod x minus 10 under root. To be defined, the inside expression of under root should be greater than 0. That is, modulus of x minus 10 should be greater than 0, or at the most, let's say equal to will also do. Okay. Okay, mod x minus 10 greater than or equal to 0. So what do we have? So we have that modulus of x should be greater than or equal to 10. And this part we have already studied in the inequalities chapter. In the inequalities chapter, I have told you the modulus. Inequalities related to modulus. Inequalities related to squares of a function, reciprocals. Inequalities related to modulus. This is your batch only. Okay. Just revise that part. Inequalities related to modulus, and there from there you will get that modulus of x should be greater than or equal to 10. So you have that, sir, x is either to the right side of 10 or to the left side of negative 10. This is, if it is to the left of negative 10 also, then also the magnitude is greater than 10. Yeah. The answer is x belongs to minus infinity to minus 10 union 10 to. Okay. Dhananjay, in the chat box, just write f for infinity. Don't bother about typing the whole infinity word. F will suffice. Okay. So this will be the answer. Modulus of x minus 3 plus modulus of 4 minus x is equal to 1. Solve this equation. The starting hint for this question is, for all the values of x, this function is not defined by a single formula. Depending on where actually x lies on the x-axis, what is the value of x in the some intervals. Some intervals you will have to define means like this. For modulus of x function, we divided it into two intervals. Which were the two intervals? X greater than or equal to 0, less than 0. Similarly here also, you will have to divide the x-axis into some intervals and define the function accordingly. Is the x to root of 10? No. No. Okay. Actually, there are infinitely many solutions for this equation. Dhananjay have pointed out only two of those equations. X minus 3 mod and 4 minus x mod. Generally is the case that I am used to seeing the expression in the form of x minus something. It is my habit that I generally have the habit of seeing the coefficient of x as positive. So now here x minus 3 modulus, let it be as it is. Now 4 minus x mod is there. So instead of writing 4 minus x mod, if I write x minus 4 mod, are they one and the same thing or are they different? Let me check. If I, what is my question? My question is whether of, instead of writing 4 minus x mod, if I write x minus 4 mod, whether they are one and the same thing. So my ultimately my question reduces to whether of writing modulus of y and modulus of minus of y. Can I write them interchangeably? Can I write them to be equal? So this case is easy to observe. Yes, sir. You write modulus of y or instead you write modulus of minus y. They are one and the same thing. Modulus of 5 below. Yeah, modulus of 5 minus 5 below. They are one and the same thing. So you can definitely write. So without any botheration, I will clearly just interchange 4 minus x to x minus 4, its modulus. Now this is equals to 1. So now here, for this my interval, the critical points of this are, see, x minus 3 modulus, there is one critical point 3, one critical point which is equal to 3, and another critical point x is equals to 4. What is the meaning of this critical points where the function changes its definition? This word we have already heard, critical points, by solving linear inequalities, where we used to change the signs of the function and all those things. The behavior of the function changes, the signature of the changes. These things we have done. Do you recall that in the linear inequalities chapter we have done? Everybody? So
Yes, sir.
now, for if x is greater than 4, for x is greater than case 1, x being greater than or equal to 4, what do we have? What is the first function? X minus 3 modulus. It is means right of 3. Right of 3. So x minus, consider this x minus 3 to be equal to y. So this y, if I just consider it, so modulus of y, since it is right of that 3, so y is positive. So y is positive means x minus 3 positive. So modulus of y is y itself. So the function reduces to x minus 3 mod addition. Modulus of x minus 4 will be x minus 4 only. And this is equals to 1. So the equation reduces to 2x, 7 is equals to 1. So if you solve this equation, you get 2x is equals to 8 and x is equals to 4. But this is true only if x is greater than 4, greater than or equal to 4. Okay, this original condition should be satisfied. X greater than or equal to 4, only then can you say that x is equal to 4. So okay, in the complete interval greater than or equal to 4, my only solution is, sir, x is equals to 4. This is my one solution for the interval in the checking all the points greater than or equal to 4. Now case 2, we will check for x's lying between 3 and 4. So take it greater than or equal to 3. Now equal to 4 possibility I've already considered. Why I'm taking here less than 4 and here greater? The modulus function we changes sign accordingly here. Greater than or equal to 0, less than
Sir,
0.
your voice is breaking, sir.
Voice is breaking.
Yes, sir.
Give me 2 minutes. I'll just change my location.
-4.
See, minus 3.4 will be somewhere over here. See, -1, -2, -3. Here it is -4. So minus 3.4, where does it lie? So minus 3.4, it lies over here. Do you agree with me? So that is my minus 3.4. So the
-3 we should write, sir.
yeah, minus 3. Ceiling function of minus 99.9.
-99.
Yes, correct. It will be minus 99 and ceiling function of 52 is equals to 52 only. It's an integer.
Yes, sir.
Okay, ceiling function. The reverse process now. Ceiling function of x is given to be equals to 4. So range of x. Three to five, Pujita. Maybe it's a typo error. 3 to 5 will it be? Dhananjay, answer is correct. Ceiling function is 4. So the least integer greater than that particular x. So you are probably this much should be clear from the last experience of greatest integer function. The greatest integer function that we solved. This much should be clear. So that either the x's lies in the purple interval or they lie in the blue interval. Only this purple or blue interval we have to check. Useless to us as of now. So can you see that if the answer lies in the blue interval, if the blue interval would have been our answer, the ceiling function of that blue interval, all the x's between 4 and 5, the least integer greater than x will be greater than or equal to x will be 5, not 4. So blue interval is not our answer. The purple interval is our answer. So all the x's between 3 and 4, that is definitely true. Now, if x equal to 3, the ceiling function is 3 itself, the least integer greater than or equal to 3. So it will be 3 itself, but we don't want 3.
Yes, sir. Now I got it.
It should be equal to 4. Equality at 4 is allowed. Okay. Step function of x is equals to minus 101. Range of x is equals to 0. What do you think? Again, Pujita, check whether that interval which you have written, whether that interval is possible or not. The same mistake you are committing. That interval, whether it is possible. Dhananjay also same mistake. Whether that interval is possible, both of your answers are something like this. Pujita's answer is -100, -101, and Dhananjay's answer is -101, -102. Correct. Now forget about the inequalities. I am not bothering about the equalities at the end points. -100 is to the right side. Now Pujita is writing sir -100 to the left and 101 to the right. So -100 to the left. So x is greater than -100. So for Pujita, x is greater than -100 means here should be your x. And x should be at the same time, sir, x should be less than -101. X should be less than -101 means it should be to the left of -101. How is it possible? Earlier also I told you make it a proper habit to picturize, write the inequalities properly. X greater than 5 or 5 less than x. They are exactly the habit to write this way. Means 5 less than means x is to the right of 5. X greater than 5 means where it will lie? It will lie to the right only. No? So right it will lie to the right side on the number next. So make it a habit to write 5 less than x. Are you understanding this?
Yes, sir.
Dhananjay also same mistake you did. Dhananjay, are you getting your mistake also?
Yes, sir.
The answer should be what? Now the ceiling function is -101. So either it is the purple interval or it is the blue interval. If it is the blue interval, can you see that for that particular all those blue values of all that x, the ceiling function that is least integer greater than that blue values will be -100. We want the answer to be -101. So our actual x's should be in the purple range. What is the purple range? Between -102 and -101. So I will write -102 is to the left, -101 is to the right. This way first I will write. And what about the equality at the end points? At the end points, equality at -101 is allowed, but not at 102. Okay. This will be my answer. Clear?
Yes, sir.
Now the graph of this also, it's similar to the greatest integer function or greatest integer function only. Just it will be shifted 1 unit upwards.
Sir, one more sum you give, sir.
1 minute. I will give you. Don't worry. Zero. For between 0 and 1, between 0 and 1, can you see that the graph will be, sir, at x equal to 1? And what about the end points of that interval at x equal to 0 and x equal to 1? At x equal to 1, the graph will be 1 only. Yes, correct. But at x equal just greater than 1, just greater than 1. Okay, between 1 and 2, it is at x equal to 2. Between 1 and 2. Okay. So if you approach x equal to 1 from the right direction, so means 1.1, 1.01, 1.001, 1.0001, 1.00001. The graph it is will be constant at 2, y equal to 2. Okay, the image axis equal to 2. But at x equal to 1, it is 1. So how do you convey this message? You take a hollow circle over here. So at x equal to 1, it is the solid point, that is this one. But just greater than 1, it's the graph jumps here. At x equal to 2, it will be a solid point over here. Just greater than 2, so hollow point over here. So at x equal to 2, there is a hollow point over here, just greater than 2. Keep in mind the nature of hollow points and solid points also. Here will be hollow point, here will be hollow point. 1 minute, I'm committing some mistake. Yeah, sorry, this is not the. Here it will be at x between -1 and 0, the ceiling function is 0. Between -1 and 0, the ceiling function is 0. Here at x equal to -1, here is the hollow point. At x equal to -1, it is here. At x equal to -2, it is here. At x equal to -3, it is over here. Between -1 and -2, the ceiling function is this way. Hollow point. Hollow point. Clear, everyone? Difference between greatest integer function and the greatest integer function and the ceiling function. Greatest integer function, see that the solid point, the graph, the solid point is to the left, hollow point is to the right in an interval. In an interval 1 and 2, the solid point is to the left, hollow point is to the right. Here, the solid point between 1 and 2, solid point is to the right, hollow point is to the left. That is one difference. Also, between 1 and 2, the greatest integer function is 1. Sorry, the greatest integer function here. The greatest integer function for this interval is 1. While the ceiling function for that very interval is 2, not 1. Can you see? Only these are the only two differences. Otherwise, both follow the step pattern. Clear?
Yes, sir.
Okay. Pujita, in starting you said you have some doubts about the school, and you can ask them now.
Yes, sir. One sum they gave, sir. Can I read out that sum, sir?
Okay. Dhananjay, if you want to continue, you can continue. Even if you leave, no problem. Okay. Pujita, ask the doubt.
K greater than 0.
K is greater than 0.
The product of the roots of the equation.
Product of roots of equation
Square.
X square
Minus 3kx.
Minus 3kx.
Plus 2 into.
Plus 2 into.
E power 2 log k.
Sorry, repeat again.
E power 2 log k.
E to the power.
Yes, sir.
E to the power 2 times
2 log k.
2 log
minus 1. Yes, sir.
Log k. Okay. 2
Yes,
log
sir.
k
Minus 1
minus 1
is equals to 0.
is equals to 0.
Is 7, sir.
Is
Is 7. 7. Then the sum of the roots is
then sum of the
roots
roots is.
Sir, options also they gave, sir.
Tell me the option. 1 minute.
2, 4, 6, 8. Option A, 2, sir.
2, 4, 6, 8.
Yes, sir.
Okay.
That's it, sir.
Now tell me here, e raised to the power 2 times log k minus 1. So whether it is log of bracket k minus 1 or log k subtraction 1, it is. Whether k minus 1 is in bracket.
No, sir. No brackets, sir.
Okay. This is 2 times e to the power 2 times log k, correct?
Yes, sir.
Okay. So let's solve this. So first of all, why did I ask this question whether it is log of in bracket k minus 1 or log k minus 1? That creates a difference. I hope you understand that.
Yes, sir.
Yes or no? Log
Sir.
of k minus 1. This will be different than log k. These are different things. So since they have not given the bracket, so we will just assume. Now here this is log k, and here since they have given this base e, so this exponent, I am assuming that the base of this logarithm they want it to be e only, not the natural log, not the common logarithm 10. Okay, I told you there are 2 types of logarithms with base 10 and base e. So what's the quadratic equation? X square minus 3 times k x addition 2 times e raised to 2 log k to the base e subtraction 1 is equals to 0. This log of k to the base e, I could have also written ln k. That also means one and the same thing. I have told you this part in logarithm, common log and natural log. Yes or no?
Yes, sir.
So now product of the roots is 7, correct? Product of the roots is 7. Product of the roots is 7. They have given in this part. So product of the roots of a quadratic equation, you know that it is c upon a. This part we have already seen.
Yes,
Quadratic
sir.
equation separate chapter only we did. So c upon a, product of the roots, alpha beta is equals to, given it is equals to 7, and it is equals to actually c upon a. So 2 times e raised to 2 ln k, can I write now in short? This is my c.
Yes, sir.
Upon a is 1, correct? So 7 is equals to 7 over 7, 2 times e raised to 2 log k minus 1. Now here, this is,
Sir, ln k means log k, no, sir?
yes, ln k means log k.
Okay, sir.
Ln k means log k, and that too with the base e.
Okay,
That
sir.
is the meaning of ln k. Base is e, we use ln. If base is 10, we can just write log, log k, and ignore the base. That means just ignore means even if you don't write, that is understood. So now this is equals to 2, forget as it is. This is 2, forget means 2. E raised to difference of 2 powers. This is one thing. E raised to this blue 2 times this blue thing, subtraction 1. Do you, in exponents we know that a raised to m minus n. When do we do a raised to m minus n? We do the subtraction of powers only if it is a raised to m
Sir.
divided by a raised to
A
m.
raised to n.
So I will do this e raised to 2 log k divided by e raised to 1. Divided by e raised to 1, can I write upon e?
Yes, sir.
Okay. 7 is equals to, this is e raised to 2 log k upon e raised to 1. Now 2 log k is there. So 7 is equals to 2. This upon e as it is. Okay. Now e raised to 2 log k. So 2 log k, can I bring this k over here? Now see, what my target is, how to think that I'm telling you. This is e, and the power of this e is again log k to the base e. So I think this property will be helpful to me over here. A raised to log b to the base c is equals to b raised to log c to the base a, or for that matter, the corollary of that case, the corollary of that is a raised to log b to the base a is equals to b, the base of the exponent and the base of the logarithm. That is same, so I can just directly write it as b. The corollary, you know, this b and a get interchanged. Do you remember this property?
Yes, sir.
So,
Sir, then where will go -1, sir?
-1 we have already brought it. No, this is e raised to 2 log k subtraction 1. So I've already done upon e.
Yes, sir. Yes, sir. Okay, sir. Okay, sir.
That upon e we have already taken care of. That -1. -1 means upon e we have already taken care of. Now e raised to 2 log k. Now here it was actually a raised to log something. Now what to make sure, what to do of this 2? So that 2 I will bring inside. That 2 I bring inside. So it becomes e raised to log of k square. Now this k square complete log to the base. Now it's e raised to this thing. So it will be 7 is equals to 2 upon e as it is, and this e raised to log of k square. So can I write it equal to k square?
Yes, sir.
Okay. So k square is equals to 7 times e upon 2. Okay. Now leave it here as it is. Now what he has asked, now don't try to simplify it. E is a some irrational number, 2 point something. Don't try to find the actual value of k. What he has asked is the sum of the roots. Okay, so the sum of the roots will be 3k times. Mine answer is not coming in integer. The way I have written it is correct.
Yes, sir. I think so. Here they gave -1 down, sir. You wrote 2 log k -1, no, sir.
-1 I have written in the exponent. They have given -1 downwards.
Yes, sir.
2 log k -1. So in that case, it will be the c changes. So this is 2 log k subtraction 1. So here it is 2 log k subtraction 1. Okay. So now two log k subtraction 1. This upon e will be e raised to 2 times e raised to 2 log k. That will be there as it is. I'm just making the corrections as you said. Because if 1 is in the exponent, the answer will not be the integer. Okay. The final answer that we are getting, the answer is not an integer. Have you understood the process? But
yes, sir. Yes, sir.
so 1 I'm taking downwards as it is in the question. So 2 times e raised to 2 log k 2. Now e, it won't be upon e. We don't have to bother that upon e as it is. Okay, this 2 will just directly go over here. We took upon e because initially it was -1 was in the power. That's why we took upon e. Now we don't have to bother about that. and this here 2 times this upon is not there, subtraction 1, 2 times k square, and here it is subtraction 1. Is it okay up till now?
Yes, sir.
Okay, so now if you just solve this equation, 7 plus 8 upon 2, that is 4, is equals to k square. So by this equation, k is equals to 2 or minus 2. But given that k is greater than 0, but given k greater than 0 is given, the question only it is given that k is greater than 0. Okay, otherwise log k is also not defined. If k is not greater than 0, log k is also not defined. So because of that, we will discard this value of negative 2. K will be equal to 2, and since k is equals to 2, what is my sum of the roots? Alpha plus beta is equals to minus of b upon a, which is equals to minus of, what is b? B is negative 3k, or a is 1. B is my negative 3k upon a is 1. So the answer is ultimately 3k, and 3k is what? 3 multiplied by 2, which is 6.
Option C.
Yes.
Sir, once you zoom it, sir, I'll take a screenshot. Okay, sir.
Some part is left downwards, that also.
Yes, sir. Yes, sir. I did.
Okay.
Okay, sir. Thank you, sir. Sir, one more sum, sir.
One more doubt.
Small sum, sir. Yes, sir. Multiply 3 minus 2i by its conjugate, sir.
Multiply 3 minus 2i by its conjugate.
Yes, sir. Sir, I got the answer 3 by 13 plus 2 by 13i.
When you multiply a number by its conjugate, the answer will always and always be a real number. Keep this in mind.
Okay, sir.
And that to a positive real number. Because see, a minus a plus bi is a some complex number. Correct? What is the conjugate of this complex number? Where a and b both are real. A and b both are real. Okay. What is the A and B both belong to real numbers. What is the conjugate of this? Sir, it is real part will be paired. It is the imaginary part, B. We take its negative, opposite, the additive inverse, A minus B. Correct? And we have to multiply it. Multiplying a number with its conjugate. Now do this multiplication, Pujita. What it will become? A square, A plus BI, A minus BI. This BI into negative BI. So it will be minus of B square, I square. I square is minus 1. So minus of minus B square will be plus B square. Correct?
Yes, sir.
AB into I, negative AB into I. That will get cancelled out. So what
Yes.
only remains is A square plus B square. That is sum of squares of two real numbers, which is always positive. Or at the most you can say equal to 0 if both A and B are 0. That is multiplying the conjugate 0 by its conjugate. The conjugate. Otherwise, if you get any complex number other than 0, the multiplication of a number and its conjugate will be a positive real number. So 3 minus 2i, what will be the conjugate? The conjugate is 3 addition 2i. Yes or no?
Yes, sir.
Just multiply it. It will be 3 square addition 2 square, which will be 9 plus 4, 13.
I got it. 3 plus 2i by 13. So if we, yeah, I got
3 plus 2i by 13 is not the conjugate.
then we have to divide, no sir, 3 by 13 plus 2 by 13i.
No, what is the complex number given to you? 3 minus 2i, that's it.
Yes, sir.
So the conjugate of 3 minus 2i.
Yes, sir.
If z equals to, z is given to be equals to 3 minus 2i, then z bar conjugate of z, it is equals to 3 addition 2i. No need of 13 under root 34. No need. That's it.
Okay, sir.
That is the definition. You have to just take the opposite of the imaginary part. Opposite means the additive inverse.
Thank you, sir.
Okay. Any more doubts?
No doubt, sir. Done, sir.
Okay.
Thank you, sir.
Okay. So we'll stop over here.